Alright students, today we're continuing our lessons on circles with notes 10.5. And in 10.5 we're going to apply other angle relationships in circles. So looking here at this page, we have 3 theorems to cover, and all of them dealing with circles and these angles formed. Angles can be formed by a line that could be a tangent line, it could be a secant, it could be a chord. So it could also be a ray. So those are the kinds of things that you need to look for. In this first theorem that we're going to cover, it says if a tangent, which is the tangent line, remember it only touches the circle at one point, and a chord, remember the chord is what touches the circle at 2 points and it goes through the circle, intersects at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so I'm going to start with angle 1. Now angle 1 intercepts this arc here, which is arc AB. So that's going to be 1/2 the measure of AB. And then angle 2 intercepts this arc, which is BCA, or you could call it ACB, it doesn't matter. That's going to be 1/2 the measure, but you have to use 3 letters because they gave you 3. ACB is what I'm going to call it. Okay, I'm going to skip this and go on to the next one. Here I've got angles inside the circle theorem. So if you look, you've got the point of intersection is inside the circle. You have 2 chords intersecting, and it's inside. Over here you had a chord and a tangent intersecting, and it was on the circle. So here, if 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so what that means is you have angle 1 right here, and the intercepted arc is right here. Now its vertical angle is going to be over here. Remember, they're equal, so the intercepted arc is going to be right here. So what we do to find the measure of this one, it's going to be the average of those 2. So we're going to add them together and divide them by 2. So it's 1/2 the measure of arc AB plus the measure of arc CD. You could call it DC, but I'm just doing it in alphabetical order here. There you go. Alright, the next one, the measure of angle 2, it's going to be the average of those 2 arcs. So it's going to be 1/2 the measure of AD plus the measure of BC. Okay, and again I'm going to skip this one and go to the next one. Here we have angles outside the circle theorem. If a tangent and a secant, look here, you've got different ones. Here we've got a tangent and then a secant, it touches at 2 places. Here this tangent touches at 1. You could also have 2 tangents. So here you've got a tangent and a tangent, so there's 2 tangents. Or you could have 2 secants intersect outside a circle. So each one of those, the where those are intersecting is going to be outside the circle. Then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Okay, so we've got 3 different situations going here, so I'm going to show each one of them. Here, angle 1, we're going to take this large arc here, we just take the large one, and we're going to subtract off the small one. So it's going to equal 1/2 the measure of BC minus the measure of AC. Alright, then the next one, 2, that's going to be PQA. Okay, we have to list all 3 of them, so it's going to be 1/2 of the measure of PQA minus the measure of PA. Alright, and then we have this number 3. It's going to be XY, the large one, 1/2 of the measure of XY minus the measure of WZ. Okay, so you have to really pay attention to where the point of intersection is. On this first theorem, we have on the circle. So it is just 1/2 of the arc, the intercepted arc. Here, the intersection of the chord is inside the circle. And when it's inside, remember, it's the one where you add the arcs together and take 1/2. This one is just 1/2. This one is add, then 1/2. And then this one here, it's outside. And when it's outside, it's going to be subtract, then 1/2. Okay, so 1/2, add, then take 1/2, subtract, then take 1/2. All right, let's move on. Now let's do some examples. So I'm going to have some examples in this column, and then I want you to do the check for understanding over here. Then we're going to have a few more examples to do on page 3. All right, here's the first page. Let's find the measure of angle 1, and I'm going to show all the steps. I know from the theorem that the measure of angle 1 is equal to 1/2 the measure of the intercepted arc. Well, the intercepted arc is AB. That's what I know from my theorem. Now I'm going to plug in the information that I know from the diagram. So the measure of angle 1 is equal to 1/2 132 degrees, because we know that the arc is 132 degrees. Well, 1/2 of 132 is 66 degrees. There you go. And you will do this one. That's just like it. Okay, next. Here we have find EFD. Now, what the theorem tells me is that the measure of the angle is equal to 1/2 of the arc. So I'm just going to flip it around and write 1/2 the measure of the arc is equal to the angle. This is the intercepted arc, EFD. And so they didn't really give me 3 letters to write down, so I'm just going to have to call it equal to the measure of angle D. Okay, well, using my algebra skills, I know that since this is what I want to get rid of this 1/2, so I have to multiply both sides by 2. If I multiply it by 2 over here, that cancels out with the 1/2. 1/2 of 2 is 1. So just measure of angle EFD. And what I do to this side, I have to also do to this side, so that's going to be double the measure of angle D. Okay, plug in what I know. The measure of angle EFD is equal to 2 times 110 degrees. So the measure of EFD is equal to 220 degrees. And you're going to do this one. Now, be careful on this one because they're going to give you the angle and you're going to have to find, you're going to have to use your supplementary angles to find it. Okay. Next, down here. So, what I know about this is that this angle right here, which they didn't give me a letter to name this, so I'm just going to name it X. But X really represents the measure of that angle. So, I'm just going to write that down. From my diagram, I know that X degrees stands for the measure of angle GXH. Okay, then I'm going to write the information I know from my theorem. I know that the measure of angle GXH is equal to 1/2 the measure of the intercepted arcs added together, so that's going to be the measure of FJ plus the measure of GH. Okay, now I'm going to plug in from my diagram what I know. I know that this is represented by X. I know that the measure of angle FJ is 112. I know that the measure of GH is 140. Okay, now I clean it up. That's half of 252 degrees. And half of 252 degrees is 126 degrees. Alright, the next one. We have, from the diagram, I know that X is representing this angle HGF. So that's what I'm going to write up here. X degrees equals the measure of angle HGF. And from my theorem, I know that the measure of angle HGF equals 1/2 of the intercepted arcs, but it's the difference because it's outside, so we're going to subtract them. So it's going to be the large one, which is JF, the measure of arc JF, minus the smaller one, which is the measure of HF. Okay, now I'm going to plug in everything that I know. I know that this is represented in the diagram as X. I know that this is represented in the diagram as 170 degrees. I know that measure of HF is represented as 72 degrees. When I subtract these, I get 1/2 of 98 degrees. Well, half of 98 is 49 degrees. There you go. Okay, I want you to do these. Now, these two here, these three, this is just like this one, but this matches this one down here, and you have to use some additional information. In other words, you know that this angle right here and this angle right here, they're supplementary, so keep that in mind. This one here, this is just like this one, where the intersection is outside, and we are already given the angle. We need to find the measure of the other arc, the large arc. So you're going to plug it in, and then you're going to use your algebra skills. The next one over here, now this one's a little tricky. So if you take a look, you're going to be using Pythagorean theorem. You know that from C to the circle, this is 2. But from the circle over to E, that's a radius. So you know that this whole side is 4 plus 2, which is 6. So what you know is that CE equals 6. Okay. Then we also know that this is going to be equidistant, that this one is going to match this one. So we know that this is an angle bisector. So there's some information here that you need to pay attention to as you try to find the measure of A. So all I'm asking you to do is try this one. If you can't get it, that's okay. Bring it in and we'll go over it. But I am asking you to try it in order to get full credit. All right, let's go to the next one. Okay, so here I'm not going to write as many details down, but I'm still going to show my work. Okay, so on the first one, it says that we have two secant lines. Well, the theorem doesn't mention two secant lines, but remember that two secant lines form chords. So here's a chord, and here's a chord. And those chords are intersecting inside. So we're going to use that second theorem, which is angles inside the circle theorem. Okay, so I know these two arcs. It's going to be easier for me to find y. So I'm going to find y first. Y will equal 1/2 the two arcs added together. That's going to be 130 plus 156. Okay, so y will equal, that's going to be 286. And so half of 286 is going to be 143. So y is equal to 143 degrees. Okay, so now I know y. To get x, I know that x and y are supplementary. I know that x plus y equals 180 degrees. I'm going to plug this in here for y, so that's x plus 143 equals 180. And then to get x, all I have to do is subtract. So when I subtract 180 minus 143, I get 37 degrees. Okay, so I found my x and I found my y. And I didn't show as many details, but I did show work, and that's required. All right, the next one. Here we have an intersection. We've got a tangent and a secant, and the intersection is outside, so this is the subtraction one. So to find the measure of angle MON, it's going to be 1/2 the large one minus the small one. The large one is 178 minus 76. 178 minus 76, that's going to be 102. So half of 102 degrees. So we know that the measure of angle MON is equal to 51 degrees. All right, so again, I didn't show as many details, but I did still show work, which is required. All right, the last one. Here, I've got two tangents. The intersection is outside, so this is a subtraction one. So I have to subtract the two arcs. So the large arc minus the small arc. But, as you can tell, the small arc is missing. So that's what I have to do first. I have to find, step one is to find the measure of KJ first. And then, step two would be to find X. Okay, so first, I know that the measure of the small arc, which is KJ, plus the measure of the large arc, which is not KJ, it's KLJ. That's how you can tell the difference. When you add those together, it's going to be 360 degrees. It's going to go all the way around the circle. We know the large one is 247. So the measure of KJ plus 247 equals 360 degrees. Subtracting 247 from both sides, you get 360 minus 247, which is 113. So the measure of KJ is 113 degrees. Okay, so now it's time to find x. We know that x is going to equal half of the large one, which is 247, minus the small one, which is 113 degrees. Okay, so 247 minus 113, that's 134 degrees. Okay, so that means that I have to cut that in half, and I get 67 degrees. Okay, again, you're going to try the 4 check for understanding problems, and make sure you bring those in with you to class so that you can get full credit. All right, that's it for notes 10.5.